Back. Let us go through the question. Two stones are thrown up simultaneously from edge of a cliff 200 meter high with initial speeds of 15 meter per second and 30 meter per second. Verify that the graph shown in the figure correctly represents the time variation of the relative position of the second stone with respect to the first. Neglect air resistance and assume that the stones do not rebound after hitting the ground. Take g to be 10 meter per second squared. Give the equations for the linear and curved parts of the plot. As both the stones are being accelerated due to gravity, its effect will come on the relative motion only when one of them reaches the ground. Till that point of time, the relative velocity of the second stone would remain the same with respect to the first stone. Let us consider the upward direction to be positive. V1 is 15 meter per second, V2 is 30 meter per second. So V relative would be V2 minus V1, that is 15 meter per second. The initial velocity of the first stone is 15 meter per second. Displacement from the point it has been thrown to the final point in its motion is 200 meter, and the acceleration is minus g, which is minus 10 meter per second square. And now using the second equation of motion to find out the value of t, we can find out the value of t to be 8. For this much time, the relative distance changes with the relative velocity. So maximum relative distance is v relative into t, that is 15 into 8, which gives 120 meter. The graph is therefore correct till 8 seconds. But after that, the second stone will be moving towards the first stone with acceleration g towards 8, and their relative distance will keep on decreasing from 120 meter till it becomes 0. The velocity of the second stone 8 seconds after it has been thrown can be calculated as follows under the first equation of motion, which is v equals to u plus at, that gives the value of v to be minus 50 meter per second. Now the time taken by it to travel 120 meter in the downwards direction can be calculated by using the same formula which has been used before, uh, which is equals to ut plus half at square, and this gives the value of t, and we find out to be 2 seconds. As the relative distance will become 0 after a total time of 10 seconds, which is the case as shown in the graph, and therefore the graph shown in figure correctly represents the time variation of the relative position of the second stone with respect to the first.